Hi everyone, this is Professor Oaks, and in this video we are going to expand this logarithmic expression here, log base 3 of the square root of 3x plus 2y to the second power, all over the quantity of 5z to the second power. Alright, so there are a couple of rules that we will use here, and one of them is the logarithm of a quotient. So we have a log base b of, say, x over y. That will be, all right, that will be log base b of x minus log base b of y. All right, so I see the division right here. So I know that the base right here is 3. And I know that, well, the numerator was the square root of 3x plus 2y squared, and the denominator was 5z squared. So I am going to rewrite this as log base 3 of, and you can put parentheses around the x and the y here as well. That's perfectly fine and probably usually the safer bet. All right, so the square root of 3x plus 2y squared minus log base 3 of 5z squared. All right, now there are really only two other rules that I am going to use here. And one thing, though, that you should watch out for is when you have a square root or any root here, all right, and make sure that you're clear on whether the entire expression inside of the logarithm is under the square root or only part of it, like one term. But here, the entire binomial, both terms, 3x and the 2y squared, are under the square root. So I am going to rewrite this as log base 3 of 3x plus 2y squared, and I'll make that to the 1/2 power, all right, and then minus log base 3 of 5z squared. So the only thing that I really did was, instead of using the square root, I used a rational exponent of 1/2 to represent that root, all right? So now, here is another logarithm rule that we can use, and one of them is log base 3, or base b even, right, to be more general, of x to a power. That will be that power times log base b of x. All right, so now I see that we have an expression with an exponent. So the exponent here is actually 1/2. And the base is actually here is 3. All right, and the base of the exponent here is 3x plus 2y squared. So now I am just going to rewrite this as, right, this log base 3 of 3x plus 2y squared to the 1/2 power as, right, 3, and then time, where is it? Oh, sorry, sorry, log base 3. So log base 3. So I don't know why I started with the 3 here, but let's just start with the p. 1/2 log base b, which is 3 of the argument 3x plus 2y squared. All right, now we still have to deal with this part over here. All right, the log base 3 of 5z squared. So here is another log rule that you can use, and it's log base b of, all right, x times y. That's log base b of x plus log base b of y. Now notice that the plus sign is not inside of the log. What's inside of the log is a multiply. Right? Just like up here, notice that what was right here was a minus, but what was inside of the log is the dividing. All right, so in both of these rules, you can only have, right, dividing or multiplying inside of the log if you want to have it broken into an expanded logarithmic expression, all right? So it's okay to have, right, 3x and then 2y squared, right? But you can't break that into separate expressions because these two terms are being added. They're not being multiplied and they're not being divided, all right? So that means that this is as far as this right here, this expression, log base 3 of 3x plus 2y squared can be expanded. Now, oh, by the way, I do want to say that even this rule right here is just a generalization of this rule right here, and even this rule is a generalization of this rule right here, right? So just try to remember though that inside of the logarithm, you can only expand it into more than one term if there is multiplying or dividing inside of the logarithm. All right, so let me look at this part right here, and I see that the base is still 3, and then I see two factors being multiplied, a 5 and a z squared. All right, so now when you do this, be very, very careful now, right? Because you have this minus here. So don't forget that this minus is right here. So I have minus, but I want to put all of what I am going to expand here in parentheses so I don't forget to distribute this minus sign. So I have log base 3 of 5 plus log base 3 of z to the second power. All right, so that was the x in this case, and that was the y in this case. Now, you see here that just like how I had the 1/2 power here, I have a power here, but it's a 2. But I can still apply this exponent rule for logarithms to expand this a little bit further. So it becomes 1/2 log base 3 of 3x plus 2y squared, and then minus log base 3 of 5, and you can put parentheses around here too, but plus 2 log base 3 of z. So again, I applied this logarithm rule for the logarithm of a expression to a power right here, right? The power rule for logarithms, to bring this 2 in front of the log base 3 of z. All right, now, if you for some reason did not believe me that log base 3 of z squared, and again, you can put parentheses around that z, and around the z squared, was equal to log base 3 of z using this power rule, then another way you could do this is log base 3 of z times z, which is log base 3 of z plus log base 3 of z. And then you see that there are two of these log base 3 of z's being added together. So 2 log base 3 of z, all right? So either way is fine, but you should end up with 2 times log base 3 of z. Now, one other thing that you might do to actually expand this expression is to distribute this negative sign right here. So I have 1/2 log base 3 of 3x plus 2y squared minus log base 3 of 5 minus 2 log base 3 of z. So that is my final answer. I cannot again expand this expression, this logarithmic expression any further, because the adding of the 3x and the 2y squared is occurring inside of this argument of the logarithm. Right, so then I check this logarithm, and this is just a single number 5 here, no multiplying or dividing or anything like that going on here either. And then this is just a single z here, no multiplying or dividing or anything like that going on here either. So there you go. That is how I would break down this expression or expand this logarithmic expression into a sum or difference of other logarithmic expressions. So I hope this helped, and thank you and have a good day.